With the lectures now regularly. Now before we start, just to revise what we have did today is that we have studied the structure of atmosphere, then we studied insolation, that is the incoming solar radiation, then we studied factors which affect the insolation, and in that we studied that how the heat budget of the earth moves, or how the heat budget what is the heat budget of the earth. In that, we studied that not all amount 100% of insolation reaches the surface of the earth, but just around 50% of incoming solar radiation reaches the surface of the earth and it heats the earth's surface. It is this heated earth's surface which then emits long wave terrestrial radiation. Why? Because the incoming solar radiations are in the terms of a short wave solar radiations which heats up the earth's surface. The earth surface, after getting heated up by the incoming solar radiation, then emits long wave radiation, and this long wave radiation is trapped by carbon dioxide, carbon monoxide, water vapor. We call these gases as greenhouse gas. This effect as a greenhouse effect, and this effect as a glass effect. Which effect? That is the trapping of outgoing terrestrial radiation. It traps and heats up the atmosphere. So what is the source of heating up of the atmosphere? Is the not incoming solar radiation but the outgoing terrestrial radiation, because the greenhouse gases, they allow the incoming solar radiation to pass through them. That means we can say they are transparent to the incoming solar radiation, but it is opaque or does not allow the outgoing terrestrial radiation to escape from the earth's surface, thus heating up the lower atmosphere, or thus we can say heating up of the lower atmosphere of the earth. Thus we can say that the earth's atmosphere is heated up by the outgoing terrestrial radiation, what we call as a greenhouse gas, glass effect, because the glass also behaves in a similar way. Now the other thing, how does the glass behave in a similar way? You must have regularly experienced in your everyday life. That is, whenever you when you park your car in hot sun, and when the car is closed, when all doors and glasses of the cars are closed, and if you enter the class after some time, the car is unbearably hot. So what is the first thing we do? We open the doors, open the windows, so that the ventilation can occur in the car. And due to this opening, what happens is the trapped outgoing radiation is removed, and the car becomes bearable, we can say, and then we switch on the AC after that, so that the car becomes much more bearable. Now the same effect happens. The incoming solar radiation enter the car through the glass, and the heat gets trapped inside the glass. Okay, and the same thing happens also on the surface of the earth. That is, the incoming solar radiation enter, heat up the earth, and the outgoing terrestrial radiation are trapped by the earth's atmosphere and the heat up the atmosphere. With this, then we did the factors. Then we did the difference between the temperature and the insolation, and we did the factors which affect the distribution of temperature. Now we will see what actually is the distribution of temperature, and with the distribution of temperature we will learn one more concept, that is the temperature inversion. So first, starting with the distribution of temperature. Now when the temperature distribution is there, obviously we are going to study the temperature distribution in two forms. That is the horizontal distribution of temperature and the vertical distribution of temperature. So these are the two heads of temperature distribution, that is the horizontal distribution and the vertical distribution. Now what do you mean by the horizontal distribution? Horizontal distribution, if we look on the surface of the earth, if we take the cross section of the earth, horizontal distribution is what is the temperature at 0 degree Celsius, 0 degree latitude, what is the temperature at 10 degree latitude, what is the temperature at 23.5 degree latitude, what will be the temperature at 66.5 degree latitude, And what will be the temperature at polar regions? Similarly for the southern hemisphere, that is the distribution of temperature according to the latitudes is known as horizontal distribution of temperature. This is the distribution of temperature. That means horizontally how is the distribution of temperature from the equatorial region to the polar region. This is the horizontal distribution that is on the surface of the earth. That is how the winds are moving, and especially the other things related. That is, this is the horizontal distribution of temperature. What do you mean by vertical distribution of temperature? That is, how does the temperature changes at 0 kilometer from the surface of the earth? Is there any change in the temperature at maybe 5 kilometers from the surface of the earth? Is there any change of temperature from 6 kilometers, etc.? That is the distribution of temperature as per the height is known as an vertical distribution of temperature. And what I said, that one word I used is temperature inversion. Now this is the concept which comes in the vertical distribution of temperature. So that the link is maintained, I will first start with the horizontal distribution of temperature. There is a small concept. The question can be describe the distribution of temperature on the surface of the earth. So you will have to give both horizontal distribution as well as the vertical distribution. Or they can ask you in the mains examination, describe isotherms in a very small way. So what are these isotherms? Isotherms are related to horizontal distribution. Explain temperature inversion. In fact, in the recent past paper, the concept of temperature inversion was asked. So you have a direct answer by knowing the vertical distribution of temperature. And obviously for the preliminary examination also, the temperature inversion concept, the distribution concept. So what you are going to study in this lecture is the distribution, the concept of isotherms, and the vertical distribution, the concept of normal lapse rate, and lastly the concept of temperature inversion, which I will take as a separate subtopic. After this, we finish the studying this distribution of temperature. Now first, as I told you, we'll study the horizontal distribution of temperature. So horizontal distribution of temperature. What do you mean by horizontal distribution of temperature? That is the temperature from equator towards the poles. Now obviously you all know, and we have studied, that the temperature on an average decreases from equator towards the poles. Yes, logically you must be knowing why it decreases. That also you know, because the sun's rays are vertical on the equator, while the sun's rays start becoming oblique, slanting sun's rays as we move away from the equatorial regions towards the polar region. Polar region में सबसे ज़्यादा slanting या oblique sun rays come. So the polar regions are the regions where the sun's rays are oblique in nature. Vertical sun's rays more energy per unit, oblique sun rays less energy per unit. Why? Because as I told you in the previous lectures, remember that you must be playing the games during your childhood, that there was a magnifying glass. Magnifying glass used to burn the paper. It used to kill an insect. Also magnifying glass used to burn the insect or burn the paper. Or the concept of solar cooker, solar heater, that is the concentration of sun's rays. So vertical sun rays jitni hai, they all get concentrated, hence they have more energy per unit area and the heat of the surface. Plus the vertical sun rays travel through a less distance, and because of this, the vertical sun rays, as they are traveling through a less distance, there is more amount of energy. On other hand, the oblique sun rays, the slanting sun rays, what I meant to say is this, we have already done this. If you can use these concepts to revise in the previous lectures. Vertical, oblique, So you see angle here is not 90 degree, यहाँ पे angle is 90 degree. So less energy, this sun's rays carry less energy, and because they carry less and less energy, they do not heat up the surface. इसलिए polar regions are colder while the equatorial regions are warmer. So what does the horizontal distribution of the temperature says? The horizontal distribution of the temperature says that on an average, temperature decreases from equator towards the poles. That is low latitudes. Equator etc. are low latitudes, 0 degree latitudes, have high temperature. While higher latitudes have low temperature. This is the first point. On an average, the temperature decreases from high latitudes towards the lower latitudes. That means the polar regions, obviously, why the polar regions, you know that the polar regions have snow covered surface throughout the year. They are known as permafrost region. That is permanently covered under the snow. The which regions? The polar regions. In fact, in India also, as you are going near the equator, that is if you go south towards the southern part of India, Indian Peninsula region, you will see that there is more and more heat. In Chennai, Mumbai, there is more heat as compared to Delhi. Obviously, because of the presence of India, presence of Himalayas, we have a different kind of a microclimate, but winters are more severe in the northern part of India. Take for example Kanyakumari and other tip of India, that is the Jammu and Kashmir region, which is more hot, which is having more average temperature. Obviously Kanyakumari has more temperature as compared to the Srinagar region or Jammu Kashmir region. Why is this? Because Kanyakumari is located more nearer to the equator. So as you are moving away from the equator, towards the poles, the temperature goes on decreasing. But there is one catch here. Now if I ask you, where is the highest temperature in the world located? Is it on the equator or is it just north or south of the equator? What are the equatorial regions? Equatorial regions, though we have not done the climatic regions, but you know that equatorial regions are the regions which are cloudy throughout the year, and therefore I have repeated this in the previous lectures also, that the equatorial regions receive rainfall throughout the year. Every day there is a rainfall which is known as 4 o'clock rainfall. So the equatorial regions, because they are, when do you get rainfall? Because they receive rainfall, obviously their temperature drops. And rainfall, what is one of the most essential condition for the formation for rainfall? कब होंगी बारिश? Initially there have to be cloud. बादल होंगे तो ही बारिश होगी. So cloudy regions, equatorial regions are cloudy throughout the year. And remember your lecture of heat budget of the earth. Clouds reflect 27% of incoming solar radiation. That means the equatorial regions may not, because they are cloud, most of the insolation gets reflected away, and as a result of this, highest temperature is not recorded on the equator, but they are recorded on the just north of the equator. That means because this equatorial regions, zero degree equator, this equatorial regions, they receive, these are the equatorial regions, they receive rainfall throughout the year. Though on an average, as you move away from equator towards the poles, the temperature goes on decreasing, but the highest temperature is not recorded on the equator, rather it is recorded on the Tropic of Cancer and the Tropic of Capricorn. That is 23.5 degree north and 23.5 degree south. यहाँ पे there will be the highest temperature which will be recorded. Why? Because these regions are cloudy throughout the year, and hence the incoming solar radiations is reflected, plus there is rainfall which decreases the temperature, but at 23.5 degree north and similarly in the 23.5 degree south, because there is no cloud cover, the insolation directly comes and highest temperature is recorded. So generally what happens, temperature decreases from equator towards the poles, but the highest temperature means where will be the summers most severe? It will be on the tropical regions. Why? Because the equatorial regions, as they receive rainfall throughout the year, plus they are cloudy, so the incoming solar radiation is reflected away, plus there is everyday rainfall also, so the temperature is decreased, while यहाँ पे in 23.5 degree the temperature is increases. So next point here in this you remember, but the highest temperature is not recorded on the equator, rather on Tropic of Cancer, that is 23.5 degree north, and Tropic of Capricorn, (23.5 south), that is Tropic of Capricorn. Because why? Because equatorial regions, because the equatorial regions are clouded, therefore reflect insolation, and receive rainfall throughout the year. And they receive the rainfall throughout the year, because equatorial regions are cloudy, they receive the rainfall throughout and therefore they receive the rainfall throughout the year. So what is the first concept in the horizontal distribution of temperature is, on an average, as you move away from the lower latitudes to the higher latitudes, or as you go from equator towards the poles, the temperature goes on decreasing. You know the reasons. If you don't watch the latitudes and longitudes lecture in the preliminary section, on an average the highest temperature, or you can watch the lecture on heat budget of the earth. That is what is called as an interlinking. Interlinking is the first and the most important step to understand any subject and to crack any examination, be it civil service examination or be it any other, because now we are focusing here on the civil service examination. So interlinking of knowledge and fixing it in your brain. Now coming to but the highest temperature is not recorded. The highest temperature is not recorded where? At the equator, on the equator, rather it is on the tropics of both, that is both the tropics, Capricorn and Cancer. Why? Because the equatorial regions are cloudy and therefore they reflect insolation and they receive the rainfall throughout the year, and because they are cloudy throughout the year. And because they are cloudy, they have only one season throughout the year, that is the rainy season. इस टाइप के रेनफॉल को कन्वेक्शनल रेनफॉल बोलते हैं, which will be doing it in the distribution of world climate, that is the study of the world climate. But if you remember, if you have gone through this year's preliminary examination paper, there was a question, what is the type of a climate, which they had given you a long statement, but what was the crux of that statement? There is a type of a climate which has similar temperature or which has similar weather pattern throughout the year. What is that climate? You have the answer here. Because the equatorial regions are cloudy, they receive rainfall throughout the year. इसलिए obviously the answer is equatorial climate or the tropical climate, because they receive rainfall throughout the year. इसलिए वहाँ पे हमेशा same type का weather pattern होता है. That is, there is the same type of a weather in this region. So on an average, again here the temperature decreases from the equator towards the poles. Highest temperature on the tropics. Why? Because the equatorial climate have the same type of climate throughout the year. Now the second is, how do we represent the horizontal distribution of temperature? Now, how do we represent then, or how do we show the horizontal distribution of temperature? Now, open your atlas, see the distribution of temperature in the world, or if you have NCERT, you must have seen the diagrams in which there will be a diagram which shows the distribution of, there will be a diagram in the box which shows the something which will be similar to this diagram. It will show the lines which move like this. See, there will be a diagram in which there will be lines which will be running parallel more or less, or there will be some kind of a divergence, and यहाँ पे there will be written the temperature such as 30 degrees, 25 degrees, 20 degrees, 15 degrees you take, 10 degrees you take, 0 degree you take like this. And similarly यहाँ पे around 20 degrees, 15, 10, 4 degrees and 0 degrees. There will be some or more these lines. Now these are the lines which are known as isotherms. So the distribution of temperature in the world, the horizontal distribution of temperature in the world is shown by the isotherms. Now these parallel lines are known as an isotherms. What are these lines, isotherms? Now listen here very properly. Isotherms are the line joining places of equal temperature when they are reduced to their sea level. Now this, what is, I will make you write again this, but understand the concept, because I will have to use the board again and you will see the diagram of isotherms in the attachments. Okay, so the isotherms are lines joining the places having equal temperature. Now the isotherms will be there in the northern hemisphere, the isotherms are there in the southern hemisphere. What can you make out from this diagram? Can we say the isotherms in the northern hemisphere, if we take this as an equator, this is the equatorial region of the world. I will draw with the blue pen. So the equatorial region this is the north hemisphere. This is the 0 degree equator. So this is north and this is the south. Can we conclude from this diagram that the isotherms in the northern hemisphere are very closely spaced? They are very dense and they are very close to each other. Is it? While the isotherms in the southern hemisphere are very, very widely spaced. And they are far away from each other, and we can say they are more or less parallel to each other. Second thing you can notice in the diagram here, the isotherms in the northern hemisphere are not actually very much parallel to the latitudes, while here in the southern hemisphere the isotherms are running more or less parallel to the latitudes. The third conclusion you can draw in the diagram, there is change in the direction of isotherms when they go from the continent towards the oceans, again when they go from ocean towards the continent, again from continent towards the oceans, from oceans towards the continent. So these are the three conclusions we can draw. What is the, again I'll repeat, what is the first conclusion? Is the isotherms are densely spaced or narrowly spaced in the northern hemisphere, while they are widely spaced, wide network spaced in the southern hemisphere. The second conclusion is they are more or less they are irregular in the northern hemisphere, while they are more or less parallel to equator, parallel to the latitudes, and regular in the southern hemisphere. The third conclusion, there is change in the direction of the isotherms when they cross from ocean to the continents and from continents towards the oceans. Now why is this there? Obviously, very logically, you just have to think what dominates in the northern hemisphere is land. What dominates in the southern hemisphere is the ocean. So the change of temperature, that is from 30 degrees it is going to 28, 25, 20, 15, 10, 0, etc. Again the change of temperature, what we call as a temperature gradient. The change of temperature because of the dominance of land. What is there on the land? Is the land a flat surface? No, land has mountains, land has hills, land has lakes, land has rivers, land has forest, land has plateau, land has glaciers, land has deserts. So there is very irregular distribution of temperature on the land. Hence, because the northern hemisphere is dominated by the land, the isotherms are irregular and very, very narrowly spaced. Why narrowly spaced? Because यहाँ पे 28 degree है, maybe there is a mountain and again there is a 25 degree, 20 degree. So that means the change of temperature is very, very high in the northern hemisphere because of the dominance of land. Now if you come to southern hemisphere, in the southern hemisphere is dominated by the ocean. Except for some continents, some narrow part of Africa, some narrow part of South America and Australia, there is no dominance of land in the southern hemisphere. There is a dominance of ocean. Ocean ke, is there a mountain of water? Is there any kind of a feature on the surface of the ocean? No, it is a plain, flat, you can say. It is the same featureless phenomena, that is, there is only water everywhere. And water, because there is a water, there is no change in temperature. Isliye the oceans at Tropic of Capricorn, 23.5 degree latitude, all these oceans will be having more or less same temperature. Equatorial regions, more or less oceans will be having same temperature. In the polar regions, the ocean will be having same temperature, that is the 0 degree Celsius, and so on. So there is no change of that, there is not that much change of the temperature in the southern hemisphere because of the dominance of oceans. So therefore they are widely spaced, and they are regular or more or less parallel to the latitudes. So this is what I meant to say. So have a look at the diagram again, and before I proceed to the next step, you see how it is done. We'll write what we have studied. What we have studied, what is isotherms? We have studied the distribution of isotherms. So how is the representation of horizontal distribution? Horizontal distribution of temperature is represented by lines known as isotherms, or we can say by isotherms. By isotherms. What are these isotherms? Isotherms are lines on the map the lines on the map joining the places of equal temperature reduced to sea level. They are lines on the map joining the places of equal temperature reduced to sea level. Means all the places, first they are the lines on the map joining the places of equal temperature. But equal temperature of a place when it is reduced to a sea level. What you mean by this is that they do not show the actual temperature of a place. For example, if there is a surface like this and which is having a mountain which is 3 kilometers, here this is a flat surface, and if on the surface of the earth here the temperature is around 25 degrees Celsius, while यहाँ पे the temperature is around 10 degrees Celsius, then the isotherms, then this 10 degrees Celsius का this mountain will be reduced to this mountain will be reduced to its sea level temperature. What will be the sea level temperature? Suppose the height of a mountain is around 3 kilometers from the surface of the earth. Then it will be reduced to 10 plus 3 into 6.5 degrees Celsius. It will come to somewhere around 29.5 degrees Celsius. So this is how the reduction of the temperature is done. Why it is done? Why to make the lines pass, that is to make the isotherms pass through it. So it will be, this area will be represented by 29.5 degrees Celsius isotherm. So maybe अगर isotherms draw करना है इस area का, this area at the sea level is having around 25 degrees Celsius. So this area will be represented by 25 degrees Celsius isotherm, but this area, this mountain, when it is reduced to 29.5 degrees Celsius, so it will be represented by another line showing 29.5 degrees Celsius. So it is not an actual temperature, but the temperature of a place when that place is reduced to the height of a sea level. Why this is done? So that for a reference point it is done. Now for a reference point means for a theoretical reason it is done. It is not much of useful for practical reason. For farmers example, farmers cannot use the lines of isotherms because farming, for the farmer the actual temperature is required, not the imaginary temperature after reducing that area to a sea level. So what you have to remember is isotherms, these are imaginary lines joining the places of equal temperature reduced to sea level. That means they do not represent the actual temperature of a place. They do not represent the actual temperature of a place, but temperature when it is reduced to sea level. So can it be useful for farmers? No, it is not useful for farmers, because the farmers require the actual temperature of a place. This is for theoretical geography, climatology. This is for theoretical importance, not for importance of a farmers. So these isotherms are the line joining areas of same temperature reduced to a sea level. This is what is the definition of an isotherm. What do you mean by reduction of a sea level? I have given you an example. If there is any mountain in the area, it will be first brought down to the sea level, and then that particular isotherm will join the place here. Now, what the second concept you have to remember is, there is, because the second concept is isotherms are irregular, closely spaced in northern hemisphere Now, why they are irregular? What do you mean by irregular? I showed you in the diagram. That is, they do not run parallel to each other like the southern hemisphere, but they are very much irregular. That is, they change their direction, they change their space. They are very nearby each other. On the other hand, in the southern hemisphere, they are more or less parallel to each other. This is what you mean by regular. This is what you mean by irregular. Now, why it is there? Because of the dominance of land. And if you ask me, how does the dominance of land affect? You already know. I have told you that because of the dominance of land, the land has numerous features on it. There is a glacier, there is a desert, there is a river, there is a lake, there is a forest, there is a very dense forest, there is a plateau, there is a mountain, and as a result, each of these climatic as well as geographical feature will have its own temperature. And hence there is a difference in the temperature on the land. Why? Because obviously dense forest mein temperature kam hoga. If there is a glacier, it is freezing temperature. If there is, say, Arunachal Pradesh, Delhi, Rajasthan, they lie in more or less same latitudes, but there is so much vast difference in the temperature. Why? Because Rajasthan is a desert, Arunachal Pradesh is the Himalayan region, Delhi is an semi-arid region. So there is so much difference in the temperature. In fact, even in the there is a difference in the temperature between Mumbai and the interior parts of at the same latitude. Why? Because Mumbai being a coastal city, it has warm and humid climate. The interior parts have hot and dry climate. So there is a difference, there is a variation in the temperature. So therefore, the isotherms are irregular, closely spaced in the northern hemisphere because of dominance of land in the land in northern hemisphere. On other hand, isotherms in southern hemisphere are wide or we can say widely spaced, or we can, first we'll write regular, more or less parallel to the latitudes, and widely spaced. Now why they are widely spaced? You know, because of the dominance of water in the form of ocean in the southern hemisphere. In the southern hemisphere. Thus, in the northern hemisphere, there is fast change in the rate of, there is a fast decrease or increase, that we can say that is, there is a rapid change in the rate of temperature increase or decrease, while in the southern hemisphere the change is very, very gradual because of the dominance of oceans in the southern hemisphere and land in the northern hemisphere. So this is the second concept here. Isotherms are irregular, closely spaced in the northern hemisphere. They are regular, more or less parallel to the latitudes, and widely spaced in the southern hemisphere. Why? Because of the dominance of land here in the northern hemisphere and the dominance of water in the southern hemisphere. Now the third concept is, hi friends, we were doing the isotherms, and this is just a continuation of that lecture. See, we did the two concepts of isotherms, that is, the isotherms are what are isotherms? Second, the definition of the isotherms, that is, the isotherms represents these are the imaginary lines which are drawn on the surface of the earth or on the map, which show places having equal temperature reduced to sea level. Not the actual temperature. You keep in mind again and again, if it comes in the preliminary examination, or if the definition of isotherms is you are expected to write the definition of isotherms in the main examination, you should know the keyword. Isotherms are the imaginary lines showing places of equal temperature reduced to sea level. The second concept which we did is that the isotherms are regular and more or less parallel plus widely spaced in the southern hemisphere because of the dominance of oceans in the southern hemisphere, while in the northern hemisphere, because the northern hemisphere is dominated by the land, it is continental hemisphere more or less rather than the oceanic hemisphere. Isotherms are irregular, very closely spaced. What does the closely spaced and widely spaced means? Closely spaced means temperature is changing at the fast rate. That is why the isotherms are very regular, because there is one isotherms of 25 degree, then if the temperature is changing at a fast rate, the nearby isotherm is of 20 degree or some other change of temperature. While in the southern hemisphere they are regular. If there is isotherm of 25 degree, the next isotherms of maybe 21 or 20 degree will be widely spaced. Why? Because there is uniform temperature. Why the uniform temperature? Featureless oceanic surface, uniform surface. There is no change in the surface. On the other hand, in the land, there are, as I told you, there are numerous physical features, plus there is a difference of soil. White soil, if the soil is of whitish or light color, it will absorb less of insolation, उसका temperature कम होगा. अगर black soil है, dark soil है, तो उसका temperature ज़्यादा होगा, it will absorb more of an insolation. Now coming to the third concept, and this is where what you should remember very, very properly. The third concept, now this is bit of a, we try to understand with the help of an example, because they may ask you in the preliminary examination regarding the direction of isotherms. Now what are isotherms? Isotherms are imaginary lines drawn on the earth's surface. Earth surface consists of both continents as well as oceans. Therefore, the isotherms will either go from, while drawing the line, you will draw the line from the Asia, and if you are going to the eastern part, you will go to Pacific Ocean, then to North America, or similarly from Asia to Europe, land. But from Europe you will have to draw it on the Atlantic Ocean. Obviously, because one is continental surface, the other is oceanic surface, the isotherms will deviate or change their direction. Now, why does the isotherm change their direction while they move from land to the ocean or from ocean towards the land? Now here comes the concept of a specific heat. You must have read many times, you know it, that the specific heat of water is greater than that of a land. That means the amount of heat. What do you mean by specific heat? The amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. 1 gram pani ka temperature, to increase it by 1 degree Celsius, how much heat you are requiring, how much energy in the form of heat you are requiring is more. For water, to raise the temperature of water by 1 degree Celsius, you require more heat, and to raise the temperature of land by 1 degree Celsius, you require less heat. So that means specific heat of water is more. Or in the simple terms, if I tell you, it means that land cools and becomes hot at a faster rate as compared to the water. Water cools and becomes hot at a slower rate as compared to the land. And here there is the application of the third concept. The isotherms when going from land towards the sea, they deviate. Obviously they will deviate polewards. They deviate polewards. Obviously they will change their direction depending upon the season. During winter season, during winters and equatorwards, during summer. So there is change in the direction of isotherms. They change their direction polewards during the winters and equatorwards during the summer season. That means we can say the January isotherms, which is the month of January in India, in the northern hemisphere, it is the winter season. So the January isotherms, if we are considering only the India, Jan isotherms, or if you are considering only the northern hemisphere, the isotherms deviate polewards during the winter season, while the July isotherms deviate equatorwards during the summer season. But when they are going from land towards the sea. When the isotherms are moving from land towards the sea, they deviate or they change their direction. They deviate polewards during the winters and they deviate equatorwards during the summer season. Now, why do they deviate? If I tell you, just try to imagine. You know that land gets hot very fast, and the land also gets cooled at a faster rate. Now, because we will first consider during the summer season, then we will go to the winter season. Now, what are isotherms? Isotherms are lines, imaginary lines. The second concept, you know that the land gets faster, cooler cooler faster as well as hotter faster as compared to the water. The third concept which you know is that as you move from lower latitudes towards the higher latitudes, there is decrease in the temperature. Now consider this diagram of an hypothetical continent we are taking. We are just considering an imaginary continent here, and we'll try to draw the isotherms. Suppose this is a continent here, and there is one more continent here. Suppose there are two continents and beach mein there is an ocean. This is the equator of the continent or the middle part of the world. 0 degrees, therefore it is an equator. Now if I want to, what will be the, now you know the concept, as you go from equator towards the polar regions, the temperature goes on decreasing. So the equator may, on the continents, suppose there is an isotherm, this is area of 30 degrees Celsius, isotherm of 30 degrees Celsius. This is an isotherm of 20 degrees Celsius. This is an isotherm of 10 degrees Celsius. Similarly here there is an isotherm of 30 degrees Celsius. The second isotherm is of 20 degrees Celsius. The third isotherm is of 10 degrees Celsius. The top में, and उसके ऊपर the again 10, 20, 30 degrees Celsius. The nearest to the equator is 30. उसके ऊपर की line is 20. So that if you can't see, this line is of 20. This line is of 10 and this line is of 30 on the continent. Now when I am trying to draw an isotherm, what is an isotherm? Isotherm is a place joining equal temperature, line joining places of equal temperature. Now because we will consider this 20 degree isotherm. Now during the summer season, what do we write? They move equatorwards during the summer season. Now during the summer season, this isotherm, this place on the world is having the temperature of 20 degrees Celsius. But that means it is hot. Comparatively it is hotter as compared to the other parts. But usi latitude mein, the similar ocean, will it be having 20 degrees Celsius? Will it be having more than 20 degrees Celsius? Will it be having less than 20 degrees Celsius? What is your opinion on that? Land gets cooler faster, land gets hotter faster. We are doing the summer isotherm. We say that the isotherms move equatorwards during the summer. In summer, land is getting hotter. So this area gets 20 degrees Celsius, means it is getting hotter. But the surrounding ocean is not as hot as the land. It is cooler as compared to that land. जो ये latitude में surrounding ocean है, it is much cooler as compared to the land. Which ocean will be hotter? The hotter ocean will be nearer to the equator. And hence the isotherms, when we are drawing this isotherm of 20 degrees Celsius, when it moves from land towards the sea, it goes towards the equator during the summer seasons. So hence it is moving towards the equator. So the isotherms, when they go from land towards the sea, they deviate equatorwards during the summer season. But consider if it is a winter season. I will use the green pen to mark the winter season. So during the winters, what will happen to this isotherm? Now suppose it is a winter season, and we'll consider again this 20 degrees Celsius wala isotherms. Are you clear with this concept? Just watch this concept. What is the direction? It is a summer season. 20 degrees Celsius is the land temperature, but uske surrounding ocean is cooler. Why? Because the water is getting cooler at a lower speed. So hotter water, 20 degrees Celsius ka water will be nearer to the equator, and hence it goes downwards, and the isotherm is moving towards equator during the summer season. Now when we consider the other isotherm, that is the isotherms during the winter. Now they are moving polewards. Why they will move polewards? Because during the winter season, this area, if it's getting cooler, suppose this area during the summer, जो हमारा 20 डिग्री सेल्सियस एरिया है, it is having higher temperature, maybe of 30 degrees Celsius. But during the winter season, land gets cooler at a faster rate. If you want to know the concept, look at the previous lectures of climatology, the factors affecting distribution of temperature. There I have explained why there is a difference between heating and cooling up of the land. Again, for you to revise, I will again explain this. One of the major reasons for the difference is land is not, the sun rays do not penetrate much deep into the land. Maximum they can penetrate up to 3 feet, while they penetrate up to 200 meters in the water. Hence, the superficial layer of the land gets hotter. So, and we are just living on the superficial layer. We do not live inside the rocks. We are living on the surface. So we can feel the surface being hotter. While on the ocean surface, because it is penetrating deep, it is taking much more time to get hotter. Secondly, land is not mobile, water is mobile. Land, we will never see that we are standing here on the land and the land is running like a river and taking us to different places. No, not possible. So, land is immobile. Immobile hai to kya hai? There is no redistribution of the heat. While in the water there is a distribution of the heat. Because of the distribution of the heat, there is a mixing up of the heat, and this entire water takes time to get warmed. Similarly, while getting cooler, superficial layers lose the heat very easily, but heat is penetrated much deeper inside the water. So land gets cooler at a much faster rate as compared to the water. Daily life example, बर्तन पहले गर्म होता है if you put on the gas, और पहले पानी गर्म होता है. It is obviously the vessel which gets hotter, then the heat is transferred to the water, then only to the upper layer of the water, and then to the inner layer, and then convectional current, conduction sets in, and then the entire water gets hot. So same concept is here. Now consider this poleward isotherms. That is, the isotherms, when they come from land towards the sea, they deviate polewards during the winters. I will rub this so that I can draw a better diagram here. Suppose यहाँ पे there is 30 degrees Celsius, there is a 25 degrees Celsius, this is 20 degrees Celsius, this is 10 degrees Celsius. On the land, again 30 degrees Celsius, 25 degrees Celsius, 20 degrees Celsius, 10 degrees Celsius on the other part of a land. But in the surrounding ocean, now I am saying winter season. In the winter season, the land is getting cooled. We will take the 20 degrees Celsius isotherm. Now the land gets cooler at a faster rate during the winters. Winter se pehle there is summer. The land is hot. Water is also hot. But when the winters come, that is when the sun goes in the southern hemisphere or in another hemisphere, because we are living in the northern hemisphere, I am taking it as a reference point. When the sun is going in the southern hemisphere, the winter sets in. When the winter sets in, the temperature starts decreasing, and when the temperature starts decreasing, obviously the land as well as water starts getting cooler. But the land is getting cooler at much faster rate as compared to the water. So this 20 degrees Celsius isotherm, if there is a 20 degrees Celsius temperature on the land, यहाँ पे in the water there will be around 25 degrees Celsius, because it is getting cooler at a much slower rate. But where will be the 20 degrees Celsius in water? Near the equator or near the poles? It will be near the poles. Why? Because again, another concept. That's why I always keep telling you in your lectures, interrelate, revise, look at the lectures again and again, make notes of what I am telling. Okay. So this isotherm, यहाँ पे there will be 20 degrees Celsius, यहाँ पे there will be 10 degrees Celsius, यहाँ पे there will be around 30 degrees Celsius. So the isotherms, when they will move from land towards the water in the winter season, they will move polewards. Again they will keep moving polewards, while they will again move equatorwards if it is going from land. Now forget about this concept, I will talk to you later. So the isotherm, when goes from land towards the sea, they deviate polewards during the winter season. That is, they move polewards during the winter season. Are you getting how it is moving polewards? While they move equatorwards during the summer season. Why? Because during the summer season, the land is hotter. So 20 degrees Celsius ka, it is somewhere somewhere near the equator, land comparatively. So this is how. And second concept is the isotherms. When going from ocean towards the continents, they bend. Now where will be they bend? They bend polewards during the summers. During summers. And equatorwards. During winters. During the winter season. Now they will bend equatorwards during the winter season. So now we already have done this concept during the summer season. During the summer season, the isotherm, when it crosses from land towards the sea, it will bend equatorwards. But during the winter season, when the isotherm goes from land, here see in the diagram, towards the sea, I will write here winters so that you don't get confused. It will go towards the pole during the winter season when it is going from land towards the sea. Now we'll extend this isotherm from sea towards the land. It is going from sea towards the land. Now in the higher latitudes, in the winter there is more cold in winter season. More cold is there in the higher latitudes, because our concept says that as we go from higher to lower to higher latitude, temperature decreases. इसलिए जितना आप poleward जाओगे उतना there will be more and more severe winters. So the land here gets cooled enough, but the water is not as equally cooled from when it is during the summer season. Why? Because land is getting cooler at a faster rate. So the surrounding water is not cooled. Now we have already done this concept. We are taking this isotherm. Now it is going from ocean and towards the continents. Now this area, when it goes, this 20-degree isotherm, when it goes near the continents, it will move equatorwards while moving from land towards the continents during the winter season. Okay, so here the isotherms, when go from ocean towards the continents, they